Hello, this is Teacher Nichols, and this video is on algebra tools. The essential question today is, how do I figure out what equation to use and find a solution to an algebra problem? When many people think about physics, they worry that there's going to be a lot of math in it. And math is a really important tool for physics. It definitely supplements what we teach, and it lets you solve problems much more efficiently than without it. But it doesn't have to be hard math. This video that we're going through today may be review for some people, or it may be new for other people, but this is about the only math that you really have to learn to be able to do well in this class. So it's worth putting the time in now. So please make sure that you watch this video. If you're confused about it or don't feel comfortable with it, ask for some extra help, because this is really critical for success in the year. But the good news is then it shouldn't be too much more math past this. So almost every physics problem that you are going to be solving will be a word problem. And while you're new to physics and while you're still sort of learning some of the tips and techniques that we use to solve problems, I would encourage you to use what's called a no-want list when you are approached with a word problem. So what a no-want list is basically one list of all of the variables that you know and another of the one that you want. Organizing our information from our word problem this way is going to help us to figure out what equation to choose and how to get to our solution. So if you had a word problem that read, a ball rolls for 5 seconds, during this time it covers 3 meters of distance, what is its average velocity? I would, on my paper, write no and want. And then every value or every number that I see in the problem is going to be a different variable. So that first one in orange, 5 seconds, that is the amount of time that is passing while the ball is rolling. So that is delta t, and if there's a math operator, you should put it into your no list if you can. So in my no list, I'm going to write delta t equals 5 seconds. Make sure you put units in your no list as well, otherwise you're going to have a hard time later on. The number in yellow, 3 meters, is the delta d, or the distance that it is covering as it's rolling. So I would write down delta d equals 3 meters. And then in the want list, we're writing the name of the variable we want to find. It says what is its average velocity, so obviously the wanted variable will be v average. After you have your no want values written down, it's time to choose an equation. Ideally, you sort of know which equation you want already. Like, you can think about the ideas that are being covered, what scenario is going on, and pick an equation that's relevant to your problem. You should remember that every equation you'll need in this class is given to you as a reference, or you could always create an equation from scratch like we did in class, but finding the equation shouldn't be the hard part. The hard part is making sure that you pick the right one. One way to know that you have the right equation is making sure that whatever equation we choose for sure has to have the wanted variable in it, because if we are wanting v average, the equation has to have v average for me to be able to solve for v average, right? So make sure that you pick an equation with the wanted variable in it. Now, there may be multiple equations that have that wanted variable in it. So to decide which one to use, you're going to ideally pick the ones that have as many of the known variables as possible. And then you're going to go ahead and just write down the equation. So for that last problem, we need an equation that has v average in it that describes the relationship between distance and time. Hopefully you're very quickly jumping to the only equation we have so far, which is this one. So you should write this down in your paper just like it exists right now. V average equals delta d over delta t. So once you've chosen an equation, next thing we're going to do is to plug in the values. So underneath the equation you chose, what we're going to do is just rewrite the equation again, but this time instead of writing the letters for anything that we know the value of, we'll write in the value in the units that we know instead of the variables. And we're going to just leave the variable that you wanted as a variable. So for example, with that no list that we created earlier in that equation, when we rewrite it, it's gonna, we're gonna plug in that delta t in that space. So we plug in 5 seconds where it says delta t, and we're gonna plug in 3 meters where it says delta d, and we're gonna have a new equation that looks like this: v average equals 3 meters divided by 5 seconds. A quick little note. You're not always going to have the wanted variable by itself on one side, right? Sometimes it will be the delta d that we want to solve and other things. So that's fine. You would just plug in wherever the variables are and just leave it leave it looking like however it looks once they're plugged in. Once you've got your variables plugged in, then you get to solve the equation. And this is the step that trips people up most of the time. Solving an equation means that you're going to get the wanted variable all by itself in the numerator on one side of an equal sign. So there's a lot in that definition. Wanted variable by itself. It has to be in the numerator, it can't be on the bottom, and it's going to be all alone on one side of an equal sign. Some examples of equations that are not solved, okay? 4 equals y minus 9, right? The y minus 9, y is my wanted variable, and it's not all by itself, okay? The next one, 4 times z equals 3. Again, not solved because the z is my wanted variable, and it's not all by itself. The last one is one that, we see a lot of mistakes made this way. Someone gets a 1 over m equals something, equals 209, but the problem is they think the m is all alone because there's just a 1 on the same side as it. But the m is on the denominator, and so you have to actually continue to work at this until the m is all by itself on the numerator. Some examples of equations that are solved, okay? Y equals 4 plus 9. Now, it doesn't have a final value, but I consider this solved because the y is all by itself on one side of the equal sign. Z equals 3 over 4. Or m equals 1 over 209. That is also a solved equation because the m is all by itself on one side of an equal sign. So if you have an equation that is not solved because your wanted variable is not all by itself, all you got to do is move everything else that is on the same side as the wanted variable until it actually is all by itself. And you move things in an equation by reversing the math operators and for all the other numbers, and that allows you to cancel those numbers out. But a quick note, whatever you do to one side of the equation, you have to do to the other side. That's how equations work. So when you are canceling out some things on one side, that means you're going to be changing the value of the other side as well. Positive at adding two things, the opposite of that is to subtract them. Divide is the opposite of multiply, etc. So let's run through a couple examples of solving some problems. I've left the units off of these just to make it go faster, but you probably should have the units in there as well. So for example, if you have 4 equals y minus 9, the y is my wanted variable. It's not all by itself, so I need to reverse the negative 9. The way you do that is you add 9 to both sides, okay? So when you do that, those 9s are canceling out, and we get left with 4 plus 9 equals y. Once that y is all by itself, you can simplify, which means that you can put this into a calculator if you want to. So 4 plus 9, you end up getting 13 equals y. Another example, 2 times z equals 3. The z is not all by itself. We want it all by itself. The thing that's keeping it from being all by itself is 2 times. So what we want to do is the opposite of multiplying by 2, which is dividing by 2. So I'm going to divide both sides of my equation by 2. And when you do that, I'm canceling out this times 2 divided by 2 on the left. And you end up getting z is equal to 3 over 2 because I divided the other side by 2. Again, you can put that in a calculator if you want and get z equals 1.5. I generally prefer decimal answers in physics because it helps me to get a better sense of where in the number line your answer is. I want to go through one special example of a problem that trips people up all year long. And that is when you have your wanted variable in the denominator. So if the variable that you want is on the bottom of a fraction, it's a little bit harder, but we're going to go through the same process. The key step to keep this from tripping you up is that we don't want the wanted variable in the denominator. So what we're going to do is we're going to multiply both sides of the equation by the wanted variable. It's kind of interesting because what that does is it actually cancels out that wanted variable on one side of the equation, but it brings it back into the other side of the equation. So it lets me get rid of the wanted variable in the denominator, but keep it in the equation, which is really useful. So if you had an equation that looked like this, 6 equals 24 over delta t, we want that delta t. Kids tend to tell me, oh, I'm going to divide by 24. You could do that. You'd get rid of the 24, but you're still going to have the delta t on the bottom of this fraction, and so we're not solved. So usually the very first step that I would do is moving that delta t, and I do that by multiplying both sides of the equations by the wanted variable. What happens then is it's canceled on this side, right? We have a delta t on the top and on the bottom, so we get rid of it, but we're left with it on the other side. And so we now have this equation that is delta t times 6 equals 24. There is now one more step that you could take. I'm not putting it on the slide, but you know, the delta t is still not quite by itself, but it's pretty straightforward. Divide by 6 to get the delta t all alone, and then you can get to the answer. So what about the units? As I mentioned, I was taking some shortcuts, but I don't want you to take those shortcuts. You should be carrying the units along with the values as you do the math. Sometimes your units are going to cancel out, which is kind of cool. Sometimes they make ugly or complicated units. That's not as cool, but still sort of a fact of life in physics. So if you had a problem using our average velocity equation where we know that 4 meters every second equals delta d over 25 seconds, our wanted variable in this problem is the delta d. I'm trying to get that all by itself. Right now it's not by itself because I'm dividing by 25 seconds. So the way to get rid of that is to multiply both sides by 25 seconds. When you do that, you will see the 25 seconds on the right cancels out, and we're left with all of this stuff on the left. 25 seconds times 4 meters every second. Hopefully you remember from our unit conversions that you can combine things different ways when you have a bunch of letters and numbers all on the same side of the fraction. It usually makes sense to put the numbers together and then the letters together separately. So if you do that here, you get 25 times 4, and then you have an S and an M on the top, and you have that other S on the bottom, right? Everything else was on the top of the fraction, and the seconds is on the bottom. On the other side of the equation, we have a nice tidy delta d because we've canceled out the 25 seconds. The cool thing, though, is that we have an S on the top and on the bottom. That means I can cancel that out, and you are left with 25 times 4, which is 100, and M equals delta d. A good way to make sure you've done this right is to make sure the units of your answer match what you're expecting, right? We canceled the seconds, we were left with the units of meters, and that's exactly what we wanted for a distance calculation. All right, we've reached the end of this video, which is on Algebra Tools. Please revisit the essential question, which is how do I figure out what equation to use and find a solution to the algebra problem? And then come talk to me if you feel like you need some extra help or support. Thanks for watching.